Hello, this is instructor Rick Powers from Western Technical College, Basic Statistics. Lesson 29, Hypothesis Testing, Introduction. Hypothesis testing is one of the most important concepts in statistics. You might notice that I said the same thing about confidence intervals. I will try to explain why that is. In doing statistics, most of the time we are using a small group, a sample, in order to get information about a larger group, the population. Traditionally, the methods of hypothesis testing have been used in research to make the connection from sample to population. However, recently, people who evaluate research have seen that hypothesis testing has been misunderstood and misused. So, confidence intervals are becoming more popular and are now considered by many people to be more realistic in drawing conclusions. One of the problems of hypothesis testing is that we have to make an assumption about a population. We assume that the population has some standard measurement and then try to see if the sample is significantly different. Note, this phrase has a technical meaning in statistics and is defined carefully. Big idea. Practical significance is different from statistical significance. Sometimes when we prove statistical significance, there's no point to it. The difference that we found doesn't matter. Every conclusion that we get from statistics should be evaluated by people who are familiar with the subject matter in order to ensure that our work has practical significance. The method of finding statistical significance is asking if the sample is an unusual event. That is, if there is a low probability that it happened just by chance. If there is a significant difference, then we might reject the original assumption about the population measurement and say that we prove a difference. For example, if you were told that a certain book club had an average age of 40, but the meeting you attended was all people over 70, then you would question what you'd been told. And the more people in the meeting, then the more you would wonder about that initial information. Again, we're looking for the probability that a sample would occur based on something we assume about the population. If there is a low probability called a low p-value, then that assumption may be false. Or maybe we can measure a z-score to see if the sample is far from the standard value. By contrast, recall that a confidence interval is an estimate based on sample data of a population measurement. We don't make any assumptions about the population before getting the confidence interval. That's not quite true. We often assume bell-shaped population data. Confidence intervals give us more information than hypothesis testing because the confidence interval will locate the population measurement for us. The result of hypothesis testing is just a statement about proving a difference in a measurement compared to some standard number that we had assumed. Sometimes both methods will give similar results. The interval may indicate a difference from a standard number. But using different methods to get to an answer allows us to verify the strength of the conclusions that we reach. Hypothesis testing has been around for a long time, and it has a lot of definitions and procedures to learn. But anyone who wants to learn from the research of the past will need to be familiar with it and evaluate its usefulness. End of lesson 29.